Here we're looking at how a decay rate and decay factor are comparable. So if you're given a rate, you're given the percentage. We're given the population in a stream decreases by 42% each year. So we're given our rate is 42%, but for our formula for exponentials, we write y equals c times a to the x. So the rate is the percent, but the factor that we need to use in the formula is not a percent. So we'd want to change that decay rate of 42% to being our a for the y equals c times a formula. So just in practice getting a, the factor, the decay factor, well, first of all, we want to divide by 100 to make it so it's not a percent anymore, which is going to give us 0.42. And then we want to think about, are we trying to grow? So should we be bigger than 1, aka do we need to add 1 to this to make it growth? Or if it's decay, we're going to subtract it from 1. So since this is decay, we're going to subtract it from 1 instead of adding 1 to it. So we're going to do 1 minus 0.42, which is going to give us 0.58 for our decay factor. A decay factor of 0.58 is perfect because it's between 0 and 1. So it definitely represents decay. If it was growth, it would be bigger than 1. So if the decay rate is 42%, the factor we need to multiply by to lose 42% each year would be multiplying by 0.58. If we wanted to lose 15% each year, we had a 15% decay rate, we'd multiply by 0.85 as our factor. You change 15% to 0.15 and subtract 1 minus 0.15. It would be a 0.85 factor. So just like this one, divide by 100. If you want it to be growth, add 1 to it. If you want it to represent decay, subtract it from 1.